just connect an LED to any pin. This is LED, and we connect this one to
D.
Ground.
That is ground or D?
Yes, this is always ground, and the other one to any D pin, let's say 5. Okay.
Okay. Okay.
And we will connect one button. Take this button.
Okay.
You will use only these terminals, 1 and 2, right?
Okay.
We cannot use this terminal and this terminal. You need to use this and this one. Otherwise, it will not work. Okay. One button. This one to any. Oh no. Its one side will be grounded always.
Okay.
And other just like LED to any D pin. Let's say I connect it at D4. Okay.
So that push button is the input, right?
Yes, it will always be input. Exactly. It's better to define variable. Int red equals red is at 5.
4 or 5? 5.
It is at 5. Button is at 4.
Yeah.
5 and int button equals 4. Okay, then wherever you connect LED, that must be output. So pin mode red output. And pin mode button is always input.
Okay.
Input pull up.
Okay.
Not only input pull up, that is necessary.
What is the difference between input and input pull up?
Pull up means when we declare any pin as input, we cannot leave it floating. We must connect it to ground, or we must connect it to 5 volt or 3.3 volt.
Okay.
We cannot leave it at floating. Otherwise, result can be very unpredictable. Whenever you connect a button, you need to connect it to ground, or you need to connect it to high. Let me make you more clear. Okay, see. Take a resistor. I will connect it to D4 because D4 is now input, right? I will connect a resistor and I connect it to ground. Now pin 4 is connected to ground through the resistor. We must connect it to ground or 5 volt. 5 volt or 3 volt, whatever voltage is at high. Or I will need to connect it at here, 3.3 volts. See this one. Okay. That is very important. But if we, let's say, if we connect 4 or 5 buttons, we need to connect 4 or 5 these resistors as well. That makes the circuit complex. For that reason, they have given built-in resistors.
Okay.
Normally in ICs, each pin in Arduino or this IC, each pin has input pull-up capability, right? So if I connect it input pull-up, it will be internally connected to high through a resistor, connected to 3.3 volt through a resistor. We don't need to connect external resistor. That makes the circuit very simple sometimes.
Okay, ma'am. This is the inbuilt functionality of that IC,
yes,
right?
Yes. These are programmable pull-up resistors. Okay. So it must be input pull up when you connect a button. Okay, now I want to I will just write a simple function to turn on the LED, and then we will improve it.
Okay.
Okay, so I will write here if digital read 4, the button is connected at 4, and if it is 0. Okay, now see, when normally D4 is high because it is internally pulled up.
Okay.
Okay, it is high. If I press this button, it will connect it to ground. Okay, button will short, and this pin will be directly connected to ground, and it will become low. It will be 0. Now it is 1. When we press the button, it becomes 0. Okay, so these lines mean when button is pressed, because pressing the button will make it low. Okay, when button is pressed, I will just write digital write red, and that's it. That's it. Now this program will just do that if we press the button, it will turn on the LED. Okay, now see, it is off. I press the button, LED will be on. See?
Okay.
So basically we are controlling the functions of the IC with a button. Input buttons are very, very important. Okay. Now let's connect another button to turn it off. Okay, I connect another button. Let's say this button. Okay, make it red. Red means off. One side will be grounded. Whenever you connect a button, one side is grounded always.
Okay.
And other side to any. Okay, it is at D19. So I can write button G, that means green button, and in button R, that means red button. Red button is at 19. Okay, so we must write G here. That means button green, and pin mod button R. It will also be input pull up. Okay, I should have written here button G. Okay, just copy paste. And button R. It will make it low.
Okay.
So when we press the green button, light will be on. When we press the red button, light will be off. Oh, okay. There is no
void setup.
Here. There must be a semicolon at the end. Here.
Semicolon. Okay.
This semicolon is very important. Okay, now see.
Okay.
On, off.
What happens when you press on button and then red button again?
We can do what?
Press the red button. Press the red button again. Red button.
Press red button again.
Yes.
That will not work. It will be off.
Okay. Just off only, no?
If you press, it will turn it off. and now it is on. If I press it again,
The low,
and
low,
again,
low.
there will be no difference because it is to turn it
Okay.
on. We will see that later.
Right.
A
Right,
single
right.
button to turn on or off. Okay, now let's create another function. Just delete. Delay 1000. Just copy paste. It will be low. Okay, now see
This should be in the,
for blink.
that should be in the if loop, right?
That is which loop?
In that if condition.
Right now if is out. Right now if is out. I'm now see just these 4 lines are to blink the LED, right?
Yes.
And this is if. Now let's define another variable. Int d. D means delay. Let's say I put it here. D. Okay. And D here.
I didn't get that because the D.
No, let's initially.
Okay. Now it's okay.
Okay. Let's say initially it is 0. Now it is. Now, if I press the green button, the value of D will be, let's say, 100.
Okay.
If I press the red button, D is 1000.
Okay.
Now, what it will do, when I press the green button, the value of D will be 100. It will be 100 here. Delay will be 100 milliseconds. LED will blink fast. If I press the red button, delay will be 1000 and its speed will decrease.
Okay.
You can put any function you like. It is just an example.
Okay.
Okay. Now I'm going to press the red one. It will blink slow. Oh, sorry, I put green. Okay. It is at 100 milliseconds. When I press the red one, its speed will get slow. Now see. You press green, it will be fast. Press red, it will get slow. Okay. So here you can put any function. Okay, let's make it 200. No, it is blinking at 200 milliseconds, and when I press this one,
1000 milliseconds.
it will be at 1. Now see, there is a problem. Buttons are not working perfect. They work, but not perfect. Let me make it more clear. Okay, let's make it 2000. It is 2200. That means it will be very slow and very fast with buttons. Green will increase the speed, and red will decrease the speed. Okay, I press. It is 200 milliseconds. I press this one. It is at 2 seconds. Now see, this button didn't work. See? Okay, now reason. What is the reason? Let me make it clear. Now see, execution of the program is that, first of all, when program starts, it checks this line, then this line. It goes on like this. Okay, first this line is executed, then this. It goes on like this. It comes here,
Okay.
here, and after that it go here. These lines are executed, it go again here, and this loop continues. Okay, now see. Reason of button for not working is because when it is 200, it will come here, right? It will wait for 2 seconds. Program will stay here for 2 seconds.
Yes.
Right? Now see, if light is on, program will stay here for 2 seconds. If I press the button, it will not work because program is stuck here for 2 seconds. Okay. Similarly, it will get stuck here for 2 seconds also. So I need to keep this button pressed for at least 2 seconds. Now see, keep it pressed. Okay, we need to keep it pressed for 4 seconds. Okay, so this is the issue. This is an issue. Okay. When speed is slow, now see, it is 200 milliseconds. It is waiting here for 2 seconds, and it will stuck here for 200 milliseconds. 200 milliseconds is a small delay. So if I press this button for okay, so sorry, it is fast, it will slow. Now see, if delay is less, button is working fine. If delay is more, we need to keep it pressed for more time. Now see, if I press, it will not. I need to keep it pressed for at least 4 seconds. Okay, because program stuck here for 2 seconds and stuck here for 2 seconds. And when we press button, program is here, program is stop here, it will not work. So this is an issue. We will see how to solve this problem tomorrow. Today you just make this button what we did. I will send you the video.
Okay.
Today just see how buttons work. Tomorrow we will make them perfect. Okay, when we press the button, it will work. We just click and it will work fine. At the moment, because time is 2 seconds, it will stuck here for 2 seconds, it will stuck at this line for 2 seconds. And when program is stuck here, these ifs will not be checked. These ifs, of course,
the loop again and again it will not check, right?
Yes. So tomorrow we will see how we can remove this issue. Today you just watch this video and just see how input buttons work. Okay, and think about what is pull up or pull down. Okay.
Actually, this is a preliminary steps for that Wi-Fi functionalities, right?
This is what?
For Wi-Fi.
Yes, it is for Wi-Fi. In Wi-Fi we need buttons. Now see, we will create a circuit. It will work with buttons and it will work with the app also.
Okay.
When button is closed to us, we just want to turn it on or through the button. The circuit will have a button and circuit will also have an app. Both options are necessary.
Okay.
So tomorrow we will see how to improve the buttons, how to improve their function.
Okay.
Today just practice this. It is enough for today. Tomorrow we will see. It will be a bit lengthy, I think. Okay.
All right.
Tomorrow same time.
Yes.
Okay. See you.
Okay.